Good morning. First of all, thank you to all of you, and especially to organizers. I'm going to talk about asymmetric information and security design under Knightian Uncertainty. It's a joint work with Andrey Malenko, who is also here. Okay, so we start from a classical problem in corporate finance. Suppose there is an informed investor who wants to raise financing for a new project from an there is an informed issuer who wants to raise financing from an uninformed investor through the security sale. And the question is, what securities will arise in equilibrium? And the classical approach is to assume that the investor is confident to assign a Bayesian prior to different distributions of cash flows. And normally, it's also further assumed that these distributions of cash flows are ordered by some strong stochastic ordering. A typical example would be that cash flows are log-normally distributed, and the only thing that the investor is uncertain about is the mean of the cash flow, and he has a well-defined prior over this mean. And the typical standard result in this literature is that risky debt arises under certain conditions, which provides foundation for the pecking order theory of capital structure. So the question we ask in this paper is, we want to develop a theory of security design when investor has only a vague idea about the possible distributions of cash flows. And the example is, suppose you have a very young firm which has a new project which has very few comparable analogs. And more formally, we study a problem where the investor faces Knightian uncertainty about possible distributions of cash flows. The issuer offers us a security which serves as a signal. And the investor demands robustness in evaluating securities in that he evaluates every security offer according to the worst-case scenario. The interesting feature here is that the worst-case scenario will depend both on the shape of the security and the equilibrium signaling. In terms of results, we show that two most common financial contracts, risky debt and outside standard equity, arise in equilibrium of this model with only one friction, asymmetric information. And both are special contracts, but for very different reasons. The main message of the paper is that the optimal security depends on the level of the uncertainty. When the uncertainty is small, risky debt normally arises in equilibrium, while as the uncertainty increases, equity becomes more and more prevalent, and eventually it becomes the dominant source of financing. Another message is that the nature of private information matters. So while we get equity in the model where the private information is about new project, equity never arises when the private information is about assets in place. We contributed several literatures. First, to security design literature, we basically reconsider classical work by Nachman Neuer by assuming that investors take a robust approach to the valuation of securities. There is a literature on robust contracting. This literature focuses on robust approach to moral hazard, and we do robust signaling. And more broadly, we contribute to the literature exploring the role of Knightian uncertainty in different corporate finance problems. So here's the model. It's a standard model. There is a new project that requires investment K. The issuer has W and needs to raise remaining I through the security sale. The issuer knows the distribution of cash flows, F, from the project. And so for today's talk, I'll focus on the model with three states. So there are three levels of cash flows, 0, Z1, and Z2, and more general cases in the paper. The investor doesn't know F, but he knows that F belongs to the uncertainty set B. In today's talk, I'll focus on the B, which is the set of distributions within some neighborhood nu around a reference distribution G. We use total variation distance as a distance measure. However, this is not critical and mostly done for convenience. Instead of telling you the formal definition, let me show you the picture. So here on the horizontal axis is the probability of cash flow Z1. On the vertical axis is probability of cash flow Z2. And this triangle, every point in this triangle is some distribution of cash flows. And the investor considers possible only distributions that belong to this hexagon. The way to think about it is that instead of knowing precisely the probabilities of each cash flow, the investor has some confidence intervals. So he knows that F1 belongs to this interval in between G1 minus nu and G1 plus nu. F2 belongs to the interval in between G2 minus nu and G2 plus nu, and F0 is in between G0 minus nu and G0 plus nu, and so we get this hexagon. Important object in the analysis will be the zero NPV line, the blue line, and so all projects above this line have positive NPV, all projects below have negative NPV. The issuer offers security S that pays Sn in state Zn, and security satisfies standard conditions: limited liability, nobody gets negative payoff in any state, and monotonicity. High cash flows are better for both sides. The investor can either accept or reject the security offer S in exchange for I. So if S is accepted, then investor gets S minus I, and the issuer gets Z minus S once Z is realized. If S is rejected, then investor gets 0, and the issuer gets to keep W. The strategy of the issuer is a mapping from his private information F into the security offer. The strategy of the investor is a mapping from the security offer into the decision whether to accept or reject. The novel part of the paper is the valuation under Knightian uncertainty. And so formally it's done as follows. The investor has infinite amount of models of the world, and model F is simply the distribution that assigns probability 1 to some distribution F in the uncertainty set. And so naturally, if investor uses model F to evaluate security S, then it's valued at the expectation of this security according to the distribution F. After observing offer F, the investor discards certain models as unreasonable and forms a set of justifiable models, B of S, which is in general a subset of the uncertainty set B because of the equilibrium signaling. I'll tell you exactly in 2 slides how this set is formed, but now let me describe the valuation. The investor demands robustness in that he evaluates each security S by the worst case justifiable model. Formally, to find the value of the security S, he minimizes the expected value of S according to all the distributions in the set of justifiable models. And this is exactly max-mean expected utility of Gilboa-Schmeidler, with the only difference that this set B of S now depends on the equilibrium signaling. Okay, so equilibrium consists of strategies and this mapping B, which satisfy the following. So first, issuer's rationality. Each issuer type offers a security that maximizes his payoff and doesn't offer anything if there is no security whose value for him exceeds W. Second, investor's rationality. Investor accepts only securities whose valuation exceeds the required investment I. And third is BS is a set of justifiable models, which I define next. So the idea of the set of justifiable models is similar to the intuitive criterion in the standard Bayesian signaling games. So any security S, both on and off the equilibrium path, is interpreted as a signal, and the investor reasons as follows. So he takes each model F and asks the question, if I were to accept offer S, would issue of type F be weakly better off compared to what he does in equilibrium? So compared to either the security that he issues in equilibrium or not issuing anything at all. If the answer is yes, I keep F in the B of S, in the set of justifiable models. If the answer is no, I get rid of it. So, and this is how the set B of S is formed, and this is the formal definition. So if this set happens to be empty, then we assume that the investor doesn't learn anything, so B of S is equal to B. Okay, so this is the model. Now let me tell you a preview of the results, and then I'll tell you the intuition. So first of all, the equilibrium is generically unique, and it takes the following semi-Poolean form. Right? So here's our hexagon, the uncertainty set. So in this hexagon, there are different regions, colored regions, and they pool on the same security. So blue region here pools on the risky debt, red region pools on equity, yellow region pools on call option, and white region pools on no issue. So the typical equilibrium looks as follows. So interesting results are when we go to comparative statics. So let's look first at what happens as we have more and more uncertainty in the game. Suppose that the investor considers more and more distributions possible, and here it's depicted as this uncertainty set starts expanding. So what we have is that equity, at first, nobody raises financing with equity, so there is no red region. But as the uncertainty increases, more and more types raise finances with equity, and it's eventually everybody who raises financing does it with equity. So equity becomes the dominant source of financing when the uncertainty is large. Same things happen when we look at when we change the project quality. Suppose required investment K increases, so more and more projects have negative NPV. As you see again, at first, there is no red region, so nobody raises financing with equity. But as the quality depreciates, we have that this red region expands, and eventually everybody who raises financing does it with equity. Interestingly, the nature of the private information matters. So if I'll have time, I'll tell you exactly what the model, but we also have a version of the model where the private information is about assets and place. And in this model, equity never arises in equilibrium, and debt is normally an optimal source of financing. So a typical example here's a comparative statistics with respect to required investment. And as you see, as we increase the required investment, red region doesn't appear, nobody raises financing through equity. So here, the nature of private information matters. Okay, so let me walk you through the intuition for the results, and importantly, why equity arises as an optimal financing. So two preliminary observations. First observation is that for equilibrium analysis, it's sufficient to look at securities that make the investor break even. And the intuition basically is if there is some security that you offer that brings a positive payoff to investor, you can slightly decrease payoff from this security, and the investor is still going to be happy to accept it. Important result is this pricing lemma, which says that for all such securities that make the investor break even, you don't need to know this set B of S in order to determine how the security will be valued in equilibrium. And so what it says is that you need to minimize the value of the security in this orange region, which is simply the set of non-negative NPV projects within the uncertainty set B. And so intuitively, what this lemma says is that in equilibrium, what the issuer can signal is that his project has a positive NPV and worth financing, but he cannot signal any other price-relevant information. Okay, so now that we have this lemma, there are basically two cases to consider. One is the small uncertainty case, and another is the large uncertainty. And suppose first the uncertainty is small, so that all distributions in the set B have positive NPV. In this case, by pricing lemma, we have that the worst case scenario will be the same for every security, and it will be this distribution F underlying. And so, as you see, there are two securities that are issued in equilibrium, call option in the yellow region and a debt in the blue region. And under further condition, which requires that the actual distribution F and the worst case justifiable distribution F underlying are MLRP ordered, we get that this blue region, and in this blue region, debt is optimal. So what is the intuition for optimality of debt in this case? So in equilibrium, every security is underpriced. However, when the actual distribution is in the blue region, we have that the investor considers lower levels of cash flows relatively more likely compared to the higher levels of cash flows relative to the issuer. And because of that, security that provides more downside protection is undervalued less compared to other securities, and this leads to the optimality of debt. Okay, so a more interesting case is when we have a large uncertainty, so some distributions have negative NPV, some distributions in the uncertainty set have negative NPV. And let's start from the extreme case when the uncertainty is so large that the investor considers all distributions possible. In this case, I mean, as I showed before, only equity is offered in equilibrium, and it's offered in this region. And so by the pricing lemma, to determine the worst case justifiable model for every security, you need to minimize its value on this set B+. And now the worst case justifiable model depends on the type of security. So if the security is concave, then the worst case justifiable model is the zero NPV distribution, which is the most dispersed, which makes a lot of sense. So the investor is now worried that there is an upside from the project, but because he's holding a concave security, he would not benefit from this upside. On the other hand, if the security is convex, then the worst case justifiable model is this point, which is the zero NPV distribution, which is most concentrated. Now, the investor becomes worried that he's holding a convex security, but there is not much upside in the project. So now I can show why equity dominates both concave and convex securities and hence dominates any security. So let's start from concave securities. So worst case justifiable model only puts positive probability on 0 and Z2, right? So because of that, the investor's valuation of the security does not depend on how much he gets in state 1, S1. The issuer prefers to decrease S1, so he prefers decrease S1 further and further until he reaches equity. Because of that, equity is better than any concave security. Okay, now let's compare equity to convex securities. Importantly, the worst case justifiable model changes in this case. So now it puts positive probability on 0 and Z1. Now the valuation of the security by the investor does not depend on how much he gets paid in state 2. That's why the issuer prefers to decrease the payoff in state 2, so until he reaches equity again. Importantly is that if the issuer tries to decrease payoff in state 2 even further, the security becomes concave, and the worst case justifiable model switches discontinuously. And this is why the equity becomes special in this case. So equity does not care which worst case justifiable model you use for the valuation. Okay, so the large uncertainty case where the set B is large but not extreme, so that it contains both positive and negative NPV projects, is it's somewhere in between, it's an intermediate case. So as before, we have that all concave securities that make the investor break even are evaluated at the distribution psi, which is the most dispersed zero NPV distribution in the uncertainty set. And all convex securities are evaluated by the investor at the model phi, which is the most concentrated distribution in the zero NPV distribution in the uncertainty set. So everything in this cone will be equity. Everything outside will be some other security. Here we have debt and call option. And you immediately see why the comparative statics works as I showed you. So once this uncertainty set expands, the distance between psi and phi increases. So this cone expands, and the equity regions becomes larger and larger until it basically takes over everything. Importantly, we also consider a model where the private information is about assets in place. And there we get that equity is never optimal. So let me just intuitively tell you what the model is. So suppose now that instead of having W, money W, the issuer pledges assets in place whose distribution is not known. So now the distribution of cash flows from assets in place comes from the uncertainty set, and it's a private information of the issuer. Now the new project's quality is common knowledge, however, and what it does is basically for every distribution it shifts probability mass from 0 to Z2. So it makes it unambiguously good, and the NPV from this project does not depend on the distribution. So what we have is that equity is never optimal irrespective of uncertainty, and if you make similar condition as MLRP ordering of the actual distribution and the worst case justifiable model, you get that that is an optimal security. And the intuition here is very natural. So unlike in the model where the private information is about new project, when the private information is about new project, what you have is that it's possible to design, because both sides are contributing to the project, it's possible to design a security that partially aligns interests of the issuer and the investor. Here, on the other hand, we have pure adverse selection. So if I'm the issuer with the worst distribution, I'm always more willing to pledge the assets compared to the issuer with a better distribution. And because of that, the worst case justifiable model will not depend on the type of the security and will always be this F underbar. And the analysis is very similar to the case of small uncertainty. Okay, so there are several implications of our analysis. Let me just tell you three most important. First one is that the nature of private information matters. So we get that more asymmetric information means more debt financing only when we are talking about the model, when the private information is about assets in place. But the opposite is actually happening when we're talking about the private information about the new project. This is in line with Stu Meyer's intuition about how the pecking order theory of capital structure should be tested. But however, this is not the insight that we get from the classical papers. So we get that in the classical model of Nachman Neuer, when the private information is about new project, the main result is debt is optimal security, as well as when, in a classical model by Demar Zaddafi, where the private information is about assets in place, we also have the debt arises as an optimal security. Okay, the second implication is that there is a mixed evidence on the validity of the pecking order theory. What we have is that the pecking order theory works best for large mature firms, but it does a poor job at describing financing by the young, high-growth firms. And this is somewhat in contradiction to the pecking order theory, where you expect that the young, high-growth firms should have a larger asymmetric information, and that's why they should rely more on debt according to the standard intuition of the pecking order theory. This is, however, exactly the prediction that we get from our model, right? When the uncertainty is not structured and has this Knightian uncertainty, we get that as the uncertainty increases, equity becomes more and more dominant source of financing for firms. Finally, even though this is beyond our paper, but our results suggest the following evolution of capital structure. What we have is that for a young firm with little assets in place, there is normally large uncertainty about the project that the firm has. And our theory predicts that equity will be a dominant source of financing. As the firm matures, two things happen. First, it converts the new projects into assets in place. So the private information becomes more and more about assets in place. And also, there is some learning about the project that the firm has. So the uncertainty we expect to shrink. Both factors, according to our model, will push towards more and more debt financing. To conclude, we reconsider the classical problem of a design of a security by an informed issuer. And the novel feature that we have is that the investor takes a robust approach faces Knightian uncertainty and takes a robust approach to the valuation of securities. What we get is that two most common financial contracts arise in equilibrium, risky debt and standard outside equity, and they arise from a model with only one friction, which is private information about the distribution of cash flows. Two main implications is that the nature of private information matters, so we never get equity financing in the model where the private information is about assets in place. When the private information is about new project, we have that when the uncertainty is small, debt, it normally arises in equilibrium. As the uncertainty grows, equity becomes more and more prevalent and eventually becomes a dominant source of financing. Thank you.